For the first part, where we have 5 to the power of x minus y, see, I can actually express 125 as 5 to the power of 3. So I can do something like this. 5 to the power of x minus y is equal to 5 to the power of 3, which is 125. And if I break this down by removing the powers, you see that I'm left with the equation x minus y is equal to 3. We can decide to call this our first equation, which is equation 1. Before we can proceed, now we're going to look at this part. And to look at this part, it is going to involve us expressing 243 in the powers of 3. And if you check your 3 to the power of 5, that gives you exactly 243. And in that case, we can write it as 3 to the power of 5. This is what I mean. For 3 raised to the power 4y minus x, I bring it down here. 3 raised to the power 4y minus x will now be equal to 3 to the power of 5. Now notice that the bases have become the same. So I can cancel them out and I'm left with 4y minus x is equal to 5. This can be seen as our second equation, equation 2. Now that we have a simultaneous linear equation already in hand, we can solve for the values of x and y using any of the methods of solving simultaneous linear equations. For now, I'm going to use the substitution method to do that. So let's get the party started. Now, from equation 1, you would notice from equation 1 that I can simply say x is exactly the same thing as y plus 3 or 3 plus y, whichever way you choose to write it. So I'm going to substitute the value of this x, which is equal to y plus 3 into equation 2. And in that case, the equation 2 that we have will now change. It will now become 4y minus my x is going to take the place of y plus 3, okay? Because I'm substituting right here. So everything is equal to 5. Now let's solve this. This will be 4y minus y minus 3 is equal to 5. Collect like terms. 4y minus 1y is 3y, right? So 3y is equal to 5 plus 3 because 3 has to close. 5 plus 3. And when we do this, it's going to be that 3y is equal to 8. To get the value of y means to divide by 3, which is the coefficient of y. Therefore, our y is evidently equal to 8 upon 3. Okay, now that we've successfully found the value of y, which is 8 over 3, remember that we already said from equation 1 that x is equal to y plus 3. So I'm going to substitute the value of y into this equation. So I'm going to say something like this. Remember that x is equal to y plus 3. Hence, if I substitute this value, x will become 8 divided by 3, all add 3. Working it out fractionally in a fraction style, x now is going to become 3 times 3 is 9. So 9 plus 8 is 17. That leaves always 17 over 3. That is the value of x. So we have successfully found the value of x and the value of y. But that's not what we're looking for in this question. Remember from the beginning, the question said we should find the value of 2 to the power of x minus 2y. So to find the value of 2 to the power of x minus 2y, this is exactly what we need to do. 2 to the power of 2 to the power of x minus 2y is going to leave us now with 2 to the power of, what's our x? 17 divided by 3. And what's our y? Our y is 8 upon 3, which is to be multiplied by 2. So it's going to be 2 times 8 over 3, like this. Okay, let's work this out. Now we have 2 to the power of 17 upon 3 minus 2 times 8 is 16. So 16 upon 3. Now it's easier to solve. So our final answer is going to be 2 to the power of 17 minus 16 is 1. So 1 upon 3. You can leave your answer exactly like this. Or you can further simplify it in root form since this is the third root of 2. So you can write it as the third root of 2. Any of these is acceptable as the final answer. I hope this is clear enough. You can try working it out yourself to see if you've mastered it. Thanks for watching.